The title of today's talk is Improving Software Quality and Security. I'm a Senior Product Manager at Coverity. Let's get started. For companies like yours, the growing complexity of software is a necessary challenge, that your development teams need to confront every day for every product. Coverity's mission is to help you meet that challenge through sophisticated automated defect detection that allows your developers to stop hunting for those hard-to-find defects and focus on delivering high-quality, secure products to the market. There are three main drivers of software complexity today. First of all, code is pervasive in everyone's daily life. As software has expanded to provide more functionality for products and services that are critical to people's daily lives, the code bases enabling these new functionalities have exploded in size. If you drove your car to the office today or logged on to a Windows-based PC, it might be possible to interact with over 100 million lines of code before lunchtime. In today's distributed development groups, source code can come from a vast number of sources. Outsourcing and external third-party code are commonplace among many development teams, and this can introduce many quality and security challenges for the engineering company. Further complexity is added by heterogeneous infrastructure frameworks such as Java J2EE or service-oriented architectures because they're becoming more popular. For larger organizations, legacy code and the loss of institutional knowledge about that code can also add unexpected complexity to new development cycles for their existing products. Let's add some perspective to our discussion. If we consider a recent report by Forrester Research, they reviewed the impact of software defects based on the time that they are identified in your software development lifecycle. They found that catching defects late in the cycle can cost your team up to 6 times more than when Coverity can find them as you're doing the implementation. Static analysis is uniquely suited to detecting defects early in the software development lifecycle because it can automatically analyze your source code outside of a runtime environment. This allows your development teams to stay one step ahead of problems and minimizes the amount of bug detecting that falls onto your QA and operational teams. Over 350 companies have purchased Coverity, representing tens of thousands of developers that care about software quality. Here's a sampling of our customer base, and how customers in software-critical industries have selected Coverity as their source code analysis solution of choice. In working closely with these organizations, we've collaborated to ensure Coverity's analysis solution meets their needs for improving code quality and security. We're also proud of the very large organizations among our 350 plus customers that have standardized on Coverity for source code analysis to ensure that their code is Coverity clean. This means that every developer within these organizations is currently using or will be using Coverity in the future. Because of our expertise, Coverity was also selected by the DHS to be the exclusive static analysis solution for the open source community. So in addition to our expertise in analyzing commercial code, we also have a lot of expertise understanding open source code, more so than any other company. As evidence of our success since 2006, we've successfully identified more than 7,000 bugs in open source software such as Linux and Firefox. It's important to note that these 7,000 bugs have been fixed with no training by Coverity, and this underscores the ease of use of our product, Coverity Prevent. As you can see from our growth and adoption trajectory, Coverity is the market-leading provider of static code analysis because we've developed major technology breakthroughs that enable effective static analysis. Today we have 13 offices in 8 countries, and as we continue to add talent, And we continue to add the talent that our customers need to ensure the quality of their code. Here are some statistics about our field organization to support that claim. 30% of Coverity engineers have PhDs. The Coverity sales team has an average of 12 years of enterprise experience, and the Coverity sales engineering team has an average of 11 years of software development experience. Now I'd like to spend some time on this one slide that depicts the technology behind our flagship static analysis solution. We break the analysis or your code down into 3 stages, and I'll explain about each one of these in detail. So first of all, maps. Our software DNA map watches every operation of the build, not just calls to the compiler in generating that software DNA map. We require 0 changes to the build regardless of the type of build system. Some other vendors have different solutions for different build systems, and you may have to modify makefiles or make changes to your build system in order for their product to work in your environment. Ours is the right answer for all build systems. We turn that representation into our AST and make sure that it's semantically equivalent to the original code. No one else does that with the code. And if you don't do this semantic representation, how do you know that you aren't losing precision? Next, the identify stage. Coverity is the only provider of path simulation through data flow analysis, plus SAT solving to achieve 100% path coverage and 100% value coverage. This gives you the most accurate and precise analysis out of the box with false positive rates at 15% and many users experiencing less than 5%. And we can do this while scaling to millions of lines of code in just a few times of the normal build time. Lastly, we're able to resolve these defects by integrating into your SCM and bug tracking system. It's not just enough to find these bugs. We have to integrate into your workflow so that the developers are able to triage and resolve these bugs. Boolean satisfiability, or SAT, is used commercially with great success by most EDA companies, electronic design automation, and these come from such companies, or these are used, SAT technologies used by such companies in the EDA space as Synopsys and Cadence, where manufacturing a defective chip can have dire financial implications. Coverity is the first company to use SAT in static code analysis. Our patented SAT engine leverages our software DNA map to create a bit-accurate representation of a software system. This allows us to translate your code into the questions based on the Boolean values of true and false and the Boolean operators such as and, not, or. Once we do this, SAT-based solvers can analyze your code. Coverity's first available solver is the false path pruning solver, which further reduces our industry best false positive rate to under 15%. SAT will also have an important place in the ongoing innovation of Coverity Prevent. We will have 2 more solvers planned in early 2008 to check code assertions and detect critical bug categories, including integer overflows. These solvers will expand our data flow analysis capabilities to uncover greater number of buffer overflows while maintaining a low false positive rate. Another significant advancement that Coverity has made in static analysis is to detect race conditions in code. Race conditions